This meeting is being recorded.
Hello everyone, my name is Prashant. In this video, I will explain system calls using a simple restaurant analogy. Understanding the Linux system call concept is often challenging for Linux beginners. So here is my attempt to explain system calls in simple language and the role of glib. Understanding system calls. Imagine you are in a restaurant. The kitchen is like the core of the operating system, which does all the heavy work like cooking food, that is managing hardware resources such as CPU, memory, and disk operations. As a customer, you cannot go into the kitchen to cook the food directly, just as a user program cannot directly access the OS resources. Instead, you give your order to a waiter system call, who is authorized to communicate your request to the kitchen. System calls are the mechanisms through which user programs interact with the operating system. For example, when a software needs to read a file, it requests the OS to do this by making a system call. This is similar to asking the waiter to bring a specific dish. The system call acts as a request to the OS to perform operations like reading or writing data, sending network packets, accessing hardware devices, etc. The role of glib. Now imagine that instead of speaking directly to the waiter, you have a menu and a set of rules on how to order. This represents glib or GNU-C library. Glib provides a comprehensive and standard way for your programs you, as the customer, to interact with the system kitchen without needing to know the details of how the kitchen works. Glib is a library that provides a wrapper around the system calls. These wrappers make it easier and safer for programs to request services from the OS. It handles many details internally, such as setting up the correct inputs for the system call, handling the invocation of the system call, and managing the results. What happens under the hood? User program makes a request. When you write a program in C or any other language that uses glib and call a function like fopen to open a file, your program uses glib. Glib wraps the system call. Glib translates your fopen call into one or more system calls that the OS understands. For instance, it might translate fopen into the open system call. Glib prepares all necessary parameters to make the OS understandable of the request. Switch from user mode to kernel mode. System calls involve a context switch from user mode less privileged, where user applications run, to kernel mode highly privileged, where the OS operates. The switch is necessary because the OS needs to protect itself and the system's resources from direct and potentially harmful interactions. System call is executed. The kernel receives the system call and performs the necessary actions like reading the file. This is like the kitchen preparing your order. Return to user mode. Once the OS has completed the operation, the result is returned to glib, which returns it to your program. This is similar to the waiter bringing the food back to your table. Error handling. If something goes wrong, say if the file doesn't exist, glib handles the error in a standardized way and informs your program accordingly. Through this process, glib provides a consistent interface to system services across various hardware and configurations, abstracting many complexities of direct system call use and enhancing portability and security. This ensures that as a programmer, you can focus more on the logic of your application rather than the intricacies of the underlying operating system interactions. Thank you everyone for watching the video. If you liked it, please don't forget to subscribe to the channel. For more content like this, check out my book, Cracking the DevOps Interview. You can find the link in the description below.